Neoproterozoic and Paleozoic passive margin. The rocks involved in Idaho-Wyoming thrust belt are generally thick packages of sedimentary strata deposited along the passive continental margin of western North America that started to form in late Neoproterozoic time, about 700 million years ago. The figure here shows a cartoon of the geometry of these strata. The tectonic unit is known as a Cordilleran myogeocline. After rifting in the late Neoproterozoic and thermal subsidence in the early Paleozoic Cambrian through Devonian time, the passive margin was compressed in latest Devonian time by the antler orogeny and modified by areas of major subsidence during the Pennsylvanian to Permian ancestral rock orogeny. In Mesozoic time, the passive margin rocks were progressively compressed and thrusted eastward as part of the Cordilleran orogeny, forming the Idaho-Wyoming thrust belt. The upper Paleozoic marine sediments in southern Idaho are composed of limestone, auronite, dolostone, chert, siltstone, and last but not least, and my personal favorite, shale. I like shale because it can be used to make chalkboards.
Limestone is a sedimentary rock composed largely of the minerals calcite and aragonite, which are different crystals formed with calcium carbonate. Many limestones are composed of skeletal fragments of marine organisms such as coral. Limestone makes up about 10% of total volume of all sedimentary rocks. The solubility of limestone in water and weak acid solutions lead to karst landscapes, in which water erodes the limestone over thousands to millions of years. Most cave systems are through limestone bedrock. Limestone has numerous uses, including as building material, as aggregate to form the base of roads, as white pigment or filtered products such as toothpaste or paints, and as chemical feedback. Auronite, or sandstone, contains over 50% of rock fragments. Auronites most often are of gray or salt and pepper color because of the inclusion of dark rock fragments, mainly slate, phyllite, or schist, but also andesite or basalt. Auronites formed by rapid deposition in areas subject to crustal deformation. Dolostone, or dolomite rock, is a sedimentary carbonate rock that contains a high percentage of mineral dolomite. It is resistant to erosion and can either contain bedded layers or be unbedded. It is less soluble than limestone in weakly acidic groundwater, but it can still develop solution features over time. The term dolostone was introduced to avoid confusion with the mineral dolomite. The usage of the term dolostone is controversial because the name dolomite was first applied to the rock during the late 18th century and thus has technical precedence. Chert is a fine-grained, silica-rich, microcrystalline, cryptocrystalline, or microfibrous sedimentary rock that may contain small fossils. It varies greatly in color, from white to black, but most often manifests as gray, brown, grayish-brown, and light green to a rusty red. Its color is an expression of trace elements present in the rock, and both red and green are most often related to traces of iron. Siltstone. The siltstone forms from erosion of pre-existing rocks on riverbeds. The sediments pile up and compress, forming siltstone. Shale. Shale is formed as a result of many processes. These are two. The first process involves the weathering and erosion of existing silicate rock, usually igneous or metamorphic in nature, and what would normally appear in a weathering mountain range. The weathering of this rock creates clay and silt-sized particles, which are transported downslope by the erosion from wind, moving water, gravity, and ice. These small particles are carried in the farthest from their point of region and settle out from suspension in the water or wind in a process known as deposition. The second is, as more and more sediment layers are added over great lengths of time, the particles of sediment are compacted by the weight from above, and the clay particles become loosely interlocked into a rock with thin depositional layering, and that is shale. Remember, shale's Gabe's favorite.
Okay, so the Paleozoic sedimentary rocks are these blue ridges right here, which are actually mountain ranges, and they were formed through extension from the Farallon plate being subducted underneath the North American plate, and the theory is that there's a divergent boundary below. This is actually part of the Basin and Range, which is predominantly in Nevada. Some of the mountains here are the Lemhi and Beaverhead Range, Wood River, and Pioneer Mountains, the White Knob Mountains, Donkey Hills, Little Lost River, and Birch Creek. There's many faults here, and they were formed during the severe erosion. There's thrust faults as well as normal faults. Oh, I didn't see you there. Basin and Range Transitional Mountains subsection consists of the Bannock and Malad mountain ranges of Paleozoic and sedimentary and volcanic rock, such as limestone, dolomite, siltstone, conglomerate, sandstone, and volcanic materials. They've been modified by fluvial, colluvial, and residual geomorphic processes. Elevations range from 5,000 to 9,095 feet, 1,524 to 1,091 meters. Why did I read that? Can you edit that? The Paleozoic and Mesozoic era occurred 542 million years ago. It ended 65 million years ago, and that's when all of the marine sediments were deposited. Bing!